Hello everyone, welcome to Everything Yagnik. In this video, we are going to learn about Pythagoras property of a right angled triangle. And we are going to do some very interesting activity. So stay tuned and subscribe to Everything Yagnik. So let's get started. Right angled triangles and Pythagoras property. We are going to talk about it today. First of all, we are going to talk about some details of right angled triangle. Then we are going to do some activity regarding it. And then based on that activity, we are going to learn about Pythagoras property. So let's start. Let's start with right angled triangle. In a right angled triangle, the sides have some special names. The side opposite to the right angle, that is 90-degree angle, is called the hypotenuse. The other two sides are known as the legs of right angled triangle. In triangle PQR, as you can see in the figure, the right angle is at Q. So PR is the hypotenuse. PQ and QR are the legs of triangle PQR. Now, to learn about Pythagoras property, first we need to do some activity. So, let's do the activity first. For this activity, you need to cut out a right angled triangle whose legs are B and C and whose hypotenuse is A. That means the length of this side or this leg is B centimeters and the length of this leg or this side is C centimeter and the hypotenuse is A centimeter long. So now you need to cut out same 8 copies or identical 8 copies of this right angle triangle. So I have done that and I have already cut out 8 of these identical right angle triangles. So first of all, what you need to do is you have to measure this length. Just place these triangles like this and then measure this length. For me, it is B plus C because since they are identical, the length of this leg is C centimeter. So adding them together, B centimeter plus C centimeter is B plus C centimeter. So what I have done is I have drawn a square of B plus C centimeters. So draw two squares of equal size which are B plus C centimeters and then follow as this. Firstly, we place this triangle like this. Just remember, you need to place it correctly. You have to place the right angle, that is 90-degree angle, on the corners of the square. So we are going to follow this method. Okay, so let me quickly fix this. And now I have fixed them. They are on a square. And now can you see these 4 right angled triangles are forming another square. Now if we write the length of each of these sides of this square, then because this side is B and this side is C, this must be the hypotenuse A. Similarly, because this side is B and this leg is C, we must get this as a hypotenuse A. Similarly, here A is the hypotenuse. So we can see that the square is forming with the side of the length is A. Now, you know that the formula of area of a square is length multiplied by length, right? Or length square. Now, can you tell me what is the length of this square? Yes, the length of the side of this square is A centimeters. So now, can we say that the area of this square is A square? Yes. So the area of this square is A square. Now remember that we need to do this activity with two squares. So now let me do this again with different type of arrangement of remaining four right angle triangles. Do you remember? We had made 8 identical copies of this right angle triangle. So we are going to use these 4 remaining identical right angle triangles in the second square. So we will do it like this. First of all, we will arrange first right angle triangle like this, and then arrange the second right angle triangle like this. So it is forming a rectangle, right? So now we are also using the second rectangle like this. So now let me quickly fix this for you. And we are done with it. So I have fixed these triangles on this sides as like this. From the figure or from this activity, you will learn what is Pythagoras theorem or what is Pythagorean property for triangles which are right angle triangles. So now, can you see what is this length? Here there is one square forming, or we can directly say that this leg of this right angle triangle is C. That means this length must be C. Similarly, this length of this right angle triangle is C, and that's why this must be C. So can we say that this is forming C by C? And what does this mean? We can say that the area of this square is C square because its side's length is C centimeter, and that's why we can say that it is C square. Now similarly, we have the length of this side of the square is B. Again, this must be B. Similarly, the length of this right angle triangle's side is B, and hence this side must be B. So the square formed by the sides B, can we say that its area is B square? Yes, because we know that the formula of square's area is side multiplied by side or side square, and hence we can say that this is C square, the area of this square is B square, and the area of this square is A square. Now you know that these both squares which we had drawn are equal, right? They are consuming B plus C sides. So now can we say that this area of this square forming with sides A and this areas of two squares forming with side C and forming with side B, can we say that the sum of these areas of this square on this square is completely equal to the area of this square? Can you imagine? Yes. Why? Because we had taken 8 identical right angle triangles and both the squares are identical, and we had used identical 4 right angle triangles in this figure as well as this figure. So the area of this square must be equal to the area of this square plus area of this square. So what are we getting from this? A square equals B square plus C square. Okay, so we have done the activity successfully. Now let's get back to the Pythagoras property. The squares are identical. The 8 triangles inserted are also identical. Hence, the uncovered area of square A is equals uncovered area of square B. That means area of inner square of square A is equals the total area of two uncovered squares in square B. That is, A square is equals to B square plus C square. This is Pythagoras property. In a right angled triangle, let's say triangle PQR, having two legs, one leg of size B units and second leg of size C units. Here from the figure you can see that line segment PQ of triangle PQR is of length B units and line segment QR of triangle PQR is of length C units. Also, we can see that the line segment PR, which is hypotenuse of triangle PQR, is of length A units. The square on the hypotenuse is equals to sum of the squares on the legs. That is, A square is equals B square plus C square. It says that for any right angle triangle, the area of the square on the hypotenuse is equal to the sum of the areas of the squares on the legs. Now let us consider triangle whose two legs are B units and C units and whose hypotenuse is A units. Let's name these vertices P, Q and R so that the triangle PQR is a right angled triangle at Q. Now let's draw a square like this in the figure. So we can see that the square has sides of B length. So let's put that square on the leg of triangle PQR whose leg is B units long. Let us draw another square and let us put that square on the leg of triangle PQR whose length is C. Now lastly, let us draw another square and put that on the hypotenuse of length A. So now, as we know that the formula of area of a square is length multiplied by length, or we can say the formula of area of square is length square. Yes. Therefore, we can say that area of this square is B square, the area of second square is C square, and finally the area of a square which is on the hypotenuse is A square. And from the activity we know that A square is equals B square plus C square. Now the reverse of Pythagoras property is also true. If the Pythagoras property holds, then the triangle must be right angled triangle. Now let us take one example of Pythagoras property. Determine whether the triangle whose lengths of sides are 3 cm, 4 cm, 5 cm is a right angled triangle. So in this example we have to determine whether the given sides are forming a right angled triangle or not. So let's start the solution. We have 3 square is equals to 3 multiplied by 3 is equals to 9. 4 square is equals to 4 multiplied by 4 is equals to 16. And 5 square is equals to 5 multiplied by 5 is equals to 25. Now we are taking the squares of all these sides because we know that the Pythagoras property is based on the squares of sides. So now, can you find those two sides whose sum of squares is making hypotenuse square? Yes, we find 3 square plus 4 square is equals to 5 square. Therefore, the triangle is a right angled triangle. Now, let us discuss example number 2. Triangle ABC is a right angled triangle at C. If AC is equals to 5 cm and BC is equals to 12 cm, find the length of AB. Now let's start the solution. But for the solution we will need a rough figure. So a rough figure will help us. So firstly let us draw a rough figure. Let us draw triangle ACB because it is given that right angle is at vertex C. So we are drawing ACB triangle. And now let us fill out the details which are given in the question. AC is 5 cm long and BC is 12 cm long. Now we need to find the hypotenuse of the right angle triangle AB. So what is the length of hypotenuse? So we can find that length of hypotenuse from the Pythagoras property. So by Pythagoras property, we can write that AB square is equals to AC square plus BC square. Now we know what is the value of AC. The value of AC is 5 cm. So that's what we are putting in the equation. AC square is equals to 5 square plus BC square equals to 12 square. And we know what are the values of 5 square and 12 square. 5 square is equals to 25 and 12 square is equals to 144. So putting these values in the equation, we get like 25 plus 144 equals 169. Now again, we know 169 is perfect square of 13. Yes. So 13 square is equals to 169. That's why we can replace the value 169 by 13 square. That implies AB square is equals to 13 square or AB equals to 13. Hence, the length of AB hypotenuse is 13 cm. So friends, thank you for watching this video. If you like this video, then don't forget to subscribe Everything Yagnik. Stay tuned for more upcoming mathematics videos like this. Thank you.